Uh, so let's start with the discussion. So how many of you have give the contrast? Mm. And how many questions are you able to solve? Mm. Anyone? Okay, nice. So we'll start with the first question today. So first question is, I think, pretty easy. All of you have solved this question, right? So this question is saying like we have two strings given, and we have to change the first index of the strings. Like whatever in the first index of the strings, in the both strings, we have to just swap the first index. So and after swapping, we have to just output the both strings. So that's pretty easy, this question, I think. So the solution is like we have to just take the inputs of the both the string and swap the zeroth index of the both the strings, and we have to just output the strings, right? It will run. Yeah. So I don't think you have problem in the first question, right? You can like write any message if you have any problem in this question. This question is clear, I think, right? Hello. Oh. So let's move with the second question. In the second question, it is given like it is a pretty intuitive based question, if you can say. We have to find the value of x such that is sum of its multiple till the value which is like k into x is less than n, and it should satisfy this. And the sum of its multiple, we have to maximize the value of x. Like not the x, like we have to maximize the sum and print the value of x which is for maximum, like for which value is maximum. Huh. So we can put it like if you see in this question, for the value of 2, it will always be maximum except for one case, like when it is 3. Like we have to take a sum, like it is 15. Like so, if you can say like multiple of 2 will always be greater. 8, 10, 12, 14. We cannot go further out, like it should be less than 15. And if we take the sum of it, it will be maximum only for 2. Like for 2 always, except for this case like 3. 3 it will be always 3 it will be answer is 3 for 3. And except that case it will always be 2. You have to figure out this one. Like it's not that hard to figure out this. And if you see this, like you can solve it. I'm doing like some, you can also just like, you can do that also. It would also work. Like if n equals to 3, C out 3, else C out 2. That would also work. Like we don't have to take this. So this is also clear, huh? Okay, okay. Ah, yes, that's why I'm talking. I've taken sum of k in terms of n minus k, and the sum is maximum. Yeah, you can do it that like also. This is also correct. But this is way shorter, like if you have shown this. Yeah. So you have any problem in this question? Or we can move further. If you have any problem in this question, we can say. It is clear, right? Okay. So let's move with the third question. Third question is like little good. In this question, we have to count the number of good arrays such that its sum of the element A is equals to the sum of all the other elements in the array. Like we have to count it. So, do you have any approaches for this question? If you have tried. So first, let me tell like how many have tried this question. Like, tell me. Yeah, yeah, like that's the basic answer. Like we have to check this. Sum equals to 2 into max. What? Sum equals to 2 into max. We'll see that. Any other approaches? Hmm. I think let me check again. The one that yeah, we can do that. But the same discussion. We have to move the array like this. This is clear, right? We cannot take this sub-array. We have to take a sub-array which is starting from the index 0. Like this is one sub-array, this is one sub-array, this is one sub-array, this is one sub-array. We have to take this told in the question. Yeah, starting from so let's get into the question. So in the question, we saw there is a sub-array. Like take one example from the question. Let's say it was 0, 1, 2, 1, 4. 0, 1, 2, 1, 4. So in this like example, so how we can count? First, we'll take the sub-array this. In this sub-array, there is only one element present. So if we remove that element, what is the sum? It is zero, right? So this can be a good a good array. So we can increase our answer as plus plus, right? So this is a good sub-array. And if we move for this sub-array, is this a good sub-array or not? You can is yeah, there was a problem in your like approach, I think. Very dark time. We should first answer that like, is this a good sub-array or not? This zero one. No, right? And if we move to this 0 and 2, what about this? Is this good or not? I think it is also not a good sub-array. And if we move till here, What about this? I think this is a good subarray because if you can see here, the 2, if we take it as element, the sum of remaining elements are like 1 plus 1 plus 0. So it is equals to 2 is equals to 2, right? So we can also say that this is also a good subarray. This. So we can also now increase the answer. And if we take this, what is the, this is also will be a good subarray because if we take 4 as a index, then the sum will be like 1 plus 2 plus 1, it will be 4. Right. So the answer will be 3 for this test case. Like, what is the answer for this? 4? Like, 3. So how will we counting the subarray effectively? Like any data structure or you might want to suggest we want to take for effectively calculating the subarrays. Because we cannot calculate in n square because n is 2 into 10 to the power 5. It will give TLE, right? So we have to at most use the big of n log n solution. So what can we do? Like any approaches, like, if you want to say. The main catch is like we have to calculate in n log n. So see like more. How we are calculating the goods average is the also the main part. Because if you can see like this was a goods average, and if you count the sum is like remaining elements is 2, and the element which we choose is also 2, right? So we can do what, like take the sum of the subarray, like the prefix. So it is what, 4, and the element that we choose is equal to the sum by 2, right? Sum is what, 4, and sum by 2. It should be equal to sum by 2. Then we can say that it is a good subarray because we cannot take it like sum is like 9 and we can take any element because it is odd. We cannot divide it equally, right? If there is an element like 4, it is not equal because sum is not equal, right? The sum will be remaining element will be a sum of 5 and the element will be 4. So it is not equal, right? We have to check for two condition. The sum should be even. Sum must be even. Must be even. And there should be an element which is equal to its sum by 2. Right? We will check in this like the fourth. We'll check like is there any element present which is sum by 2? What is sum? 4. 4 by 2. Like there was a element present. So we increase the answer. Like in the 0, what is the sum? 0. Is there any element present which is sum by 2 which is 0 by 2 which is 0? So we increase the answer. And here for the 1, since the sum was odd, so we cannot say that this is a good subarray. Similarly, for the n equals to 3, the sum was 3. We can directly say that it is not a good subarray. For 4, we check there is an element present, so we say it is a good subarray. Same for the this subarray. The sum is like what? Sum is like 8, na? There was an sum present like 4. There was an element present like The sum was what? 8. There was an element present which sum is 4. So we took that as element. So that will also be a good suburb. So the approach is clear, right? Approach is clear too. What you have said for uh, maximum equals to maximum. Yeah, that can be also like you can say that also. Like, yeah, you have taken the max element, right? Oh yeah, that way also work. So the intuition is clear, right? In for this, like how will this solution work to everyone, right? Is there any doubt, or you can say like if you have doubt, you can say the approach. We'll see the code. We'll see. What am I doing is first taking a sum a variable and a answer variable, which will be counting how many puts are errors. So first I've taken a map and run a for loop from 1 to n. What I did is take the sum of the elements. The sum is taking like sorry, we are taking the sum and increase the store the value in the map to see like it is present or not. And at each and it each like what count we are checking like the sum is even or not and the value is present in the map or not. If the value is present in the map, like sum by 2 is present in the map, we can increase the answer and run the loop from 1 to n and simply count the answer. This will also work. Right. This code will also work. Yes. Right. This question is clear, right? Or is there any doubt? Clear, right? So let's move to the next question. So, how many of you attempted this question? Hmm. Okay. So, are you able to solve it, or you have any doubt? You are able to solve it, right? Oh, incorrect. Okay. Let's go to the problem answer. So, in this question, it is given a vector of strings where we have it is given like hash circles, right? We can see circles made of using the hashtags, and we have to calculate the uh, center of the circle. So, any approaches for this question? What you have applied? I think this is like class 10 maths, if you figure out. Telling me the approach that you have used. So let's see the question then. So in the question, what we can use is like we know this like the anyone who said, huh? I had to push the x and y coordinates into different sets of the characters uh, and then learn the average to get the central coordinate. Average of the uppermost and the lower. Yeah, I'm also going to discuss that. So we can see like we have studied this property of the circle that is like the midpoint of the coordinate of the diameter will be its center, right? Like see, if there is a circle and we have given its coordinates of its diameter, and if we take the midpoint of it, what will be it? Like center, right? This is clear, right? So we are going to use that property. So we will calculate the uppermost uh, coordinate and the lowermost coordinate and simply return the average of that. That will be our answer, right? So for calculating the index, what we are going to do is we'll check the S of I, S of I, sorry, S of I j is equals to hash the first time. If it's equal, then we'll store its coordinate and similarly do it for the last element. So how we are going to do it? Let's see to the code. Hmm. Here I have taken the vector of characters. You can also make a vector of strings that will also work. I have created this and taken input, and for the x coordinate of the uppermost index and y coordinate, I've taken first x, first y, and similarly for the last index, I've taken two variables and taken a flag variable. Why I've taken it? Let's see. I've run through all the characters of the strings one by one and see if it's equals to the hash. I'll store the first index and make the flag variable as false. So what will it happen after that? After it stored the first variable, it will make it as false. So it will never get into this if part after storing the first hash coordinates. Right. After storing, like it is true before it is true while initializing, and after taking the first value it's become false, so it will not enter in this if part again. So we successfully stored the first coordinate of the first point, uppermost point, right? And in the second part what we are doing is we are just simply storing the updating the coordinates of hash. So what will it do is first store the coordinate of this one and this one and this one. It's going like this, like it will go till this and till the last hash. It will store, and after that it will not update. So after the for loop ends, we'll see that it stores the index coordinates of the last hash, right? So after the for loops end, we can simply just print the first plus last by two and plus one. Why we are doing, because here it is based indexing, right? And we have to return the answer in one based indexing, I think. Yeah, that's why we are doing plus one. So that would also work. Hmm. Yeah. See. So any problem in this question? Like understood, right? Yes. So let's move to the next question. So this question. How many of you have tried this question? You've tried it. Are you able to solve this? Solve this? No, incorrect. Okay, let's discuss. So in this question, it has given a box of sides x, y, and z. Like in x-axis, it is x, y is y, and z is z. So we want to place a box X such that its edges are parallel to the like axis on and its volume is also equals to the value of k which is given, right? So we have to like consider two things. We will first have to take a box whose volume is this k. Where is volume is k, and we have to also calculate the number of ways we can place in that box. So we have to keep two things in mind. So any approaches for this, how we can calculate? Do you want to say any approaches? So let's see this question. Okay. So we have one box, one big box here, and we also have a small box. Let's say we are able to figure out what will be its dimension, and we just want to calculate how many ways we can put that in the box. Sorry. Hmm. Right. Let's see one of the example test cases. Like for 333, let's see. The side lengths are 3, 3, and 3. And the smaller box, let's say the volume for the smaller box. So let's take the sides as 2, 2, and 2. So how many ways we can put it this in this bigger box? Hmm. I used three nested loops. Yeah, that's why it will give TLAM because if you use three loop, if you see the constraints, these are like 2 to the power 3. So if you use like n cube, it will be 10 to the power 9. So it will not work. So the maximum you can use is n square like 10 to the power 6. So so if I'm asking like how many ways we can put in this box, like how many ways we can put. What you have calculated? X minus p plus 1. Why? Yeah, that's the number of ways we can put it. So we can put it in x, whatever the coordinates of the bigger box and the length of the smaller box minus. Like if it is 3 and the smaller side is 2 plus 1 into for the y coordinate, it is same 3 minus 2 plus 1 into 3 minus 2 plus 1. Wait. So it will be like 8 equals to, if you see 2 into 2, it will be 8. So you understood why it is like y minus a plus 1 and like this. Have you understood this? Or I explain how it is coming? Is it clear? Yeah. So if it is clear, then we have one question left, like what we can choose the dimension, right? How many ways we can choose the box so that it will give the maximum number of places we can place. So what we are going to do is run a double for loop, as we cannot run a triple for loop. So what we'll do is we'll run the value of a from 1 to n. We are doing it brute force. 1 to, like, whatever the value of x coordinate, like if it is given x, like we run from 1 to x. And similarly for b, we'll run a for loop from b equals to 1 to y. After running, we cannot run the loop for z, right? Because it will give a TLA, right? Like we were saying. So one thing we can do is, as we know the value of a and b, we can calculate the value of c in big of 1, right? There is a way in calculating c in big of 1. As you can see, we have given the volume, so we can easily calculate the value of c in big of 1. So what's the need of running third loop? We can simply just take c as what? C equals to k by a into b. That will be its value c, right? We'll take this and check if value is what, less than z. C is less than z because it cannot exceed the limit that is given z. We'll check the if it is less than z or not. If it is less, then we will calculate the number of ways we can put it in. Like what is that? Whatever we put there formula, we'll calculate our like ways equals to what? Uh, x minus a plus 1 into, similarly for y, you can like say ways we have calculated. So what we are doing is storing an answer is max of ways, max of ways comma answer, ways comma answer. Why we are doing this? Because we are checking for all the possible combination of A, B, and C, which can be formed. Like its value is 8. Like whatever will be the given volume. We'll calculate the all the possible dimension and taken the max number of ways we can put it in the box, right? And we will simply thus see out the answer. That's the answer, right? See out answer. Understood, right? Here, just We have to calculate this one in big of one. If you have figured out this one, like this one, you could solve. Understood, right? What you are doing is running a loop for C also, right? That's why it's giving TLE. If you can also calculate in big of one time, so it will not give TLE. So let's see the answer for this. What I have done is taken C as one. I have taken the input of all the values that are given and taken max answer and answer. Right. Run a for loop for a equals to 1 to less than equals to x. Similarly, for b equals to 1 to b less than y. And for c, I first check it is divided or not. Because if it's not divided, then what's the point of calculating, right? So it should be like divided for checking C. If it's divided, then I've taken the value of C as K divided by A into B. That's the side. And again, I've checked what C is less than equals to Z or not. If it is less, then we check answer equals to uh, x minus A plus 1 into this and store into the max answer because I've taken all the possible combination of the boxes, right? I've taken all the possible combination of the boxes and calculated the maximum number of ways we can put it. So it will give our answer like this. But if we also have to calculate like what is the effective box side, then it will be a difficult task. But since the constraints are given like 2 to the power 3, like we can run n square, right? So we can do it in broad way. But if the constraints are given like bigger, then we could not do this like this. It will be a like difficult task for us to do. So this question is clear, right? How we are doing it two loops. It's clear, right? Three factors, first factor, good. Three factors closest to yeah, that will be like single approaches, but it will give some. We have to also keep that in mind, like what will be x, y, and z, right, in respect to the volume. It is coming or not. It will be like difficult for calculating that in big of one. So it is clear, right? So like that's it for the session. If you want to try the F question, what do I do? I was initially trying to find it, but yeah, that's it. If you want to try like F question, I will give you the hint. You can try. Like this question is like of binary search or answer, or you can also do it in like brute way. So yeah, you want to try this question like F question or not? If you want to try, I will give you the idea. Oh, you have tried, right? So in this question, what you can do is you can apply like binary search on answer. Like how we can calculate this because if you have read the question, it is like saying we have a monster which health is like H and we have to defeat it. And for defeating, there is a possible combination of attacks which we can use. Like let's say there are four attacks, whatever its value, attack value, 9, 3, and 2, and respective its cooldown period. Like if I have used this attack, and after how many seconds I can use this attack also. Like we can also perform all the attack at once, right? But then we have to wait for the cooldown periods of all the attacks, right? If its cooldown period is 3 2, 1, like 3. So after using this attack, I have to wait for 3 seconds. Similarly, for this, after using this attack, I have to wait for 2 seconds. And similarly for this is given. And the health points will be given like 10. So what can I do? I can use all the attack at once and defeat the monster in 1 second. Right? 2 plus 9 plus 3 plus 2, it is greater than, like, sum is greater than h. I can defeat in 1 second, first second. So what you will have to do in this question is, like, iterate for the value, like whatever will the answer, it will range from like 1 to, like, whatever the limit it is given, like 10 to the power 12 or 15, let's say 15. It will be in this range, right? Whatever will be the answer. So what we'll do is binary search on the answer. How will we finding this is, first we'll calculate some time. Like, let's say at time t equals to like 100. So we'll calculate how many moves of A we have used. Similarly, how many of B, C, and D we have used. How many of attack we have used till this time, and calculate it using the help point, that is the monster. And the graph will be like false. For t equals to 1, if it is false, like t equals to 2 second, we cannot defeat it till going high. If at t equals to 10, we are able to defeat the monster, then at t equals to 11, we are also able to defeat the monster, right? Similarly, it will go till further, right? 2, 2, 2, 2. So we can binary search on this point, and we will return this true, right? What the approach, right? How we are able to solve this. Yeah, we'll calculate, and what we are doing is from I to 0 to n minus 1, x modulo ci into h. See, you try, and if you are not able to solve, then tell in the group you did. I tried of solving this earlier, but all the attack reduced the help. Hmm? Like, yeah, you can try using this approach. And if you are not able to solve this, then tell in the group. You know, you got the idea, like how we are using binary search on this. Got it, right? There is also another approach for this. You can try if you want to. But till now, if you have any doubt, you can ask, or if not, you can leave. What question you are confused? Yeah, you can say last, like how we are using binary search. This part. See, if its health is like, let's say 100, so are we able to defeat the monster in t equals to 1 second? T equals to 1 second. What is the maximum possible damage we can do to this? Like 2 plus 9 plus 3 plus 2. We are able to defeat it, you know? So at t equals to 1, what will be its answer? Like false, we cannot defeat. For t equals to 2, what will check? Since we have performed this at t equals to 2, what we can do is like wait, because we have to wait for the cooldown periods of all the attacks, right? So since this is the minimum attack, so minimum cooldown of the all the attacks, we have to wait for 1 second for the attack to again perform, right? So at t equals to 2 seconds, we cannot do any attacks. because we have no attacks left, right? But at t equals to 3 seconds, we can say since 1 second has passed, we can perform this one, right? Right? So at t equals to 3 seconds, we can do this attack, right? So at it after performing this attack, are we able to defeat it? No. Similarly, we'll calculate for t equals to 3, 4 till something which is the answer. Whatever will be the answer, I don't know what is the answer, but whatever that will be the answer of the time, we'll calculate at that point. Are we able to defeat it at that point? If we calculate, how we are going to calculate? Like, let's see, like, if the time is like t equals to, let's say 50 seconds. So how many of attacks that we have done, how many of this attack we have done? How to calculate this? Divided by like cooldown period, right? 50 minus 1. Minus 1, why, what we are doing with is because at t equals to 1 second, we have already performed, right? One attack. So what, how many time we are left at? Like 50 minus 1, 49 seconds. So at 49 seconds, how many of attacks we have performed of this one? So it will be like divided by its cooldown period. Cooldown period, we have divided it. But since we have also performed it at t equals to 1, we have also performed one attack. We will add this. See, so we have calculated the amount of damage it will do by doing only first attack. Similarly, we will calculate for this second attack, for third attack, for fourth attack. We will calculate all the damages that we'll do and add all them and check if it is greater than h or not, greater than or equals to. If it's greater than equals to h, then we can say like, yeah, we are able to defeat it. So that's what we are searching on time. On this time is here, we are able to defeat or not. Let's say like last point is here. We'll see first like midpoint. Is it are we able to defeat it here or not? If it is here, we'll move our right pointer from here and now check from here. Are we able to defeat it or not here? If we are able to defeat it, like move our left pointer from here. Similarly, reduce our sample size until we get through this point. Are we able to defeat it or not? Like here it will give false. Like move our left pointer from here. As soon as the left pointer crosses the right pointer, we will greater than or equals to, we will break the loop and give our answer. Like this is the minimum time we can defeat it. Do you get it? Okay. So if you have any other doubt, you can ask for just leave. Okay. हाँ भाई रिकॉर्ड हो गया